right, so this is December. We've got this week, we've got next week, and then we got finals week. And this being Algebra 2, this is a required final. You cannot exempt this. So we will all be having to take the final in this class. Let me look real quick to see exactly when our final is. So you can put that in your calendar. Make sure that you don't miss it. Our final will be on Wednesday, December 17th at noon. Noon. So that's earlier than our normal class time. Noon on Wednesday the 17th. We'll meet right here in this Google Meet and have the final exam. So again, this is a class you cannot exempt, Algebra 2. You can't exempt like a lot of the core classes. Your English final, your Algebra 2 final, some of the other science and history. You have to take those. Some of the other classes you have, you may not have to take the final. You have programming, so it will certainly be a grade in the grade book. It'll be the final exam for the whole semester. So I have not looked at it yet to see how many questions or how many points. It's at least 100 points because it'll be at least the size of any tests we've had. But it will be your last grade for the semester, the final exam, and it'll be on that Wednesday at noon. And I'll put reminders out of that. And I'm sure you'll see a schedule and advisory and all that kind of good stuff. The other thing I need to remember is next Monday, I will not be here. I am out. I will have a video for you to watch with the lesson. So be sure and tune in for that. Get your assignment done because that'll be the last week of classes. Now, we will meet on Monday of finals week just to go over any last questions and be ready. Probably won't meet the whole class period. It'll probably be somewhat shorter. We may look at some review stuff or something, take questions, whatever we need. But we will next week. I will not be holding class, and I won't make you come on Wednesday. I know sometimes when teachers are gone on Monday, they make you come on Wednesday. I'll have a video for you to watch in place of class. I won't punish you because I'm out Monday. Make you come Wednesday. So, but I will have a video that'll cover everything. Next week's a graphing lesson, so it shouldn't be too bad. I think we can cover it with a video, and then you can do the assignment and be ready for finals week. So with that, let's see what we got this week because we need to jump on and get the semester wrapped up for finals. See what we got to cover. Let's look at the grade screen as usual. If we go down, you should be done with the test. That was right before the break. We've got just a few things to cover. I've already got the fall semester exam on there. Module 4. Contents not yet available. So it just shows it's on there. It not available yet. Can't see it yet. I haven't set the settings up on that. But you do have down to the practice tests for Unit 4. Unit 4 will be on the final. We don't have a separate test for this unit. It'll just be included on the final exam, some questions about what we're learning this week and next week. But let's go back and see exactly which lessons we're covering today. We have polynomial long division and theorems of algebra. So these first two, we're going to see how much we can get through there. Next week, like I said, we have polynomial transformations and graphing. So let's go here and see. Close module 3, polynomial long division. This is great. You remember long division, right? Polynomials in the real world. So a cantilever is a beam that's anchored only at one end, but can still bear the weight of some force. Like you see these big cranes for the cantilever. They're used in a variety of applications, from bridges to airplanes to micro electromechanical systems. There's a good word for Scrabble right there. The amount of bending that a cantilever undergoes a third-degree polynomial function. So engineers use a third-degree polynomial to calculate how much weight that a cantilever can hold. Many real-world situations can be modeled using polynomial functions. That's why it's important to know how to use them. And one key feature is when they equal 0. That makes it easy to construct a rough graph and know how the function is going to behave. So after this assignment, we'll be able to know how can long division be used to find the factors of a polynomial function. So division of a polynomial by a monomial. So when you were first learning long division, you may not have understood its purpose, but now that you're older and wiser, you can see many uses for knowing how to divide. It's important to know how to divide. Let's say you're working in a bakery and the baker sells a bag of rolls containing 13 rolls. That's called a baker's dozen. A dozen's 12, a baker's dozen, they give you a freebie with it, 13. The baker made 158 of these rolls before leaving for the evening. He said, all right, make sure and package all these up before you leave and have them ready for tomorrow. So how many bags do you need? Do you have any extras you should try to sell that you know won't fit in another box? So this is a situation you can encounter in a lot of jobs. Just talking about it with a baker. You got to have a number of items and divide them evenly. So putting 158 rolls in groups of 13, you divide 158 by 13. So here's additional review on long division. See, if you have 158, the number you're dividing into, 13 is the number you're dividing by. So if you remember, you set that up, then 13 goes into 15 one time. Then you multiply that, put the 13 underneath the 15, subtract, you got 2. Then you bring down the next digit, so you got 28. 13 goes into 28 2 times, so you put a 2 up there. Multiply 2 times 13 to 26. You subtract, you have leftover 2. So 13 goes in 158 12 times with a remainder of 2. So you got 2 left over that won't fit in the bag. So we can say that 158 divided by 13 is 12 and 2/13. Because there's 2 of another 13 that wouldn't work. And then we can multiply it back. 12 and 2/13 times 13 equals 158. So just a little review on dividing, long division. And the steps used to divide are exactly the same when dividing integers. So when we divide polynomials, it's going to work the same way. And remember this following phrase: discovering math solutions brings rewards. That helps you to remember that first you divide, multiply, subtract, bring down the next number, and repeat. So let's look at an example of dividing 2x to the third minus 10x squared plus 18x and dividing that by 2x. This is long division with a polynomial. So that's a little different than what we're normally used to seeing. But let's check out this video.
Before you can start with the division process, you need to set up the problem. The dividend is the trinomial 2x cubed minus 10x squared plus 18x. And the divisor is the monomial 2x. Remember, the steps in the division process are divide, multiply, subtract, bring down, and repeat. First, divide. How many times will 2x divide into 2x cubed? You can think of this as dividing 2x cubed by 2x. 2 divided by 2 is 1. But what is x cubed divided by x? When you multiply variables, the exponents are added. When you divide variables, the exponents are subtracted. So 2x cubed divided by 2x is 1x squared, or just x squared. This gives you the first term in the quotient. Next is multiplication. Multiply x squared by 2x. The product is placed underneath the first term of the dividend. Then it's time for subtraction. Subtract 2x cubed from 2x cubed. Now bring down the next term. Remove the 0 since adding or subtracting a term from 0 doesn't change the value of the term. Repeat the steps of long division until all the terms of the dividend have been exhausted. Time to divide again. Divide negative 10x squared by 2x. You can think of it this way. Negative 10 divided by 2 is negative 5. But what is x squared divided by x? Subtract the exponents. So negative 10x squared divided by 2x is negative 5x to the first power, or just negative 5x. Place this above the second term of the dividend. Multiply. Negative 5x times 2x is negative 10x squared. Subtract. Negative 10x squared minus negative 10x squared is 0x squared. Bring down the next term. Again, you can remove 0x squared since it just has a value of 0. Repeat the process. Time to divide again. Divide 18x by 2x. You can think of it this way. 18 divided by 2 is 9. What is x divided by x? Think about it. What is 11 divided by 11 or 100 divided by 100? The answer to all these questions is 1. Any number or variable divided by itself will result in 1. Another way to look at it is through the subtraction of exponents. Any number or term raised to the power of 0 equals 1. So 18x divided by 2x is 9. Place this above the third term of the dividend. 9 times 2x is 18x. 18x minus 18x is 0x. There are no more terms to bring down. Therefore, the quotient has been found. The answer is x squared minus 5x plus 9. Check your work by multiplying the quotient by the divisor. This product is the same as the dividend, so the quotient x squared minus 5x plus 9 is accurate.
All right, so that is dividing. Let me back that up there. I checked it by multiplying these two factors back together. 2x times x squared minus 5x plus 9 did equal the original number underneath there. But that is a way that we factored that. We factored it. So the factors of 2x to the third minus 10x squared plus 18x is 2x and x squared minus 5x plus 9. Those are the factors. So that's a pretty cool way of factoring. Here's another example on dividing by a monomial if you want to go through it. We're not going to go through it in the interest of time, but this one divides by negative 3x. And here's what it divides into. So they go through all the steps right there, which you can certainly check out if you'd like. All right. Polynomial division of a polynomial by a polynomial. So this time we're going to divide by x minus 6. So that's more than just dividing by like a 2x or something. So let's see how this example is going to work. Is this the only video on this page? It is. Okay. So let's
divide x squared minus 2x plus 4.
Hold on. Back up.
Divide x squared minus 2x plus 4 by x minus 6. First, set up the division problem, where the dividend is x squared minus 2x plus 4, and the divisor is x minus 6. When dividing integers, the digits in the dividend were evaluated separately. With polynomials, focus on the terms. There are 2 terms in the divisor. So count over 2 terms in the dividend to determine where the first term of the quotient will be placed. When dividing a multiple term polynomial, The first term of the dividend is divided by the first term of the divisor. So ask yourself, what is x squared divided by x?
Okay, I'm going to pause that for just a second. See, here's the important things about dividing by a polynomial. There's two terms that we're using to divide, x minus 6. We're dividing by x minus 6. So we have to look at the first two terms underneath here to figure out where to put our answer. Two terms, we go to the second term, and that's where we want to put our answer up here. But when we look at what we're dividing, we only pay attention to the first term, the x divided into x squared. That's all we're looking at. Yes, Joseph, what's up?
Would it be x minus 3x?
We do not pay attention to anything but the first term only.
Oh, okay.
So even though we have this negative 6 and negative 2x, we're only paying attention to the x and the x squared. That's all we're dividing when we figure out what the answer is. So x squared divided by x is x. Now we'll follow along and see where they go from there.
Next is multiplication. Similar to division by a monomial, the quotient will be multiplied by the divisor. Multiply x by x minus 6. Be sure the quotient is distributed to both terms of the binomial divisor. Place the product underneath the first two terms of the dividend. Now it's time for subtraction. Be very careful here. When subtracting a binomial, there is a -1 that needs to be distributed to each term before like terms may be combined. Once the -1 has been distributed to each term, the subtraction sign becomes an addition sign, and the like terms may be added. Bring down the next term. Repeat the steps of long division until all the terms of the dividend have been eliminated.
Again, we're only dividing 4x by
Time
x.
to divide
first
again.
terms.
Divide 4x by the first term of the divisor x. Place this above the third term of the dividend. Since 4 is positive, it is added to the first term of the quotient. Multiply 4 by x minus 6. Subtract. Don't forget to distribute the -1. There are no more terms to bring down. Therefore, 28 is the remainder. Remainders are written as fractions, with the divisor as the denominator. The quotient of x squared minus 2x plus 4 divided by x minus 6 is x plus 4 plus 28 over x minus 6. Notice that there is an addition sign between the fraction and the rest of the quotient. This is because the remainder is positive 28 and being added to x plus 4 rather than being multiplied. You can think of the remainder as another term of the quotient.
All right, so this did not divide evenly. We ended up with a remainder, which means if we were trying to factor this, these are not the factors. These are not the factors because it does not go into it evenly. There's a remainder. So you'll want some pencil and paper because we're going to take some notes and do some sample problems with this. So you'll want to have some samples in your notes that you can use on the final and stuff. And of course, you have these videos. You can go back and review them as many times as you need to. So, all right, let's write down another example because we need to talk about something that's very important here. So I'm going to write this down and I'll switch over to our notes. Okay, if we have these two polynomials, this one's 9x squared plus 6. This is 3x minus 1. And we want to find f of x divided by g of x. So we need to set it up as a long division problem. We're taking 3x minus 1, and we're dividing it into, now watch what I do here. This is important. This is where it's easy to make a mistake. Wait a minute, Mr. Brock. I think you copied f of x down wrong. Is the f of x I wrote down here different than the f of x that's up here? No, it's the exact same f of x. It's just that I wrote in what we usually don't talk about. We only have an x squared and a 6. There's not an x term up here. Well, there is. We just never write it. There's 0 x's. There's 0 x's here. So when we're just writing down what this polynomial is, we don't put the 0 x's because that doesn't have any meaning, doesn't have any value. But when you're doing division, you have to put that back in there. Let's make a note of that. Don't forget missing terms. Very important. Don't forget any missing terms. There's an x term missing here when we look at that. Now we can do the division. Now remember, when we divide, we're only looking at the first term. But since there's 2 terms, we're putting the answer above the second term up here. So how many times does 3x go into 9x squared? Well, if you divide 9x squared by 3x, 3 goes into 9 3 times, x goes into x squared x times. X squared divided by x is x. 9 divided by 3 is 3. So this is 3x times. Now, just like regular, like if we're dividing 19 by 4, let's say 191 by 4, make it more digits. You know, when we do, this goes in there 4 times, we multiply and put it underneath there. This works exactly the same way as just regular long division you learned in grade school. Multiply and put it underneath. 3x times 3x, 9x squared. 3x times negative 1 is minus 3x. Then what did we do? We subtracted. 19 versus 16 is 3. Here, we're subtracting. I'm going to put that in parentheses so we don't get confused. If I'm subtracting 9x squared minus 9x squared, that's 0, right? There's nothing there. But 0x minus negative 3x. Subtracting a negative means I add that 3x. So this is a positive 3x. Because 0 minus negative 3. Now you might see why this is important. If we didn't have this and we just had the plus 6, how would we subtract 3x from 6? We have to have like terms to do subtraction. We would have had a problem with the 6 minus 3x because it's like, I can't do that. But I can subtract 3x from 0x because they're both the like terms. Okay, now what do we do? Well, over here, we brought down the next term, so it's 31. Over here, we bring down the next term, so it's 3x plus 6. Then we took 4 and divided into 31, so that's 7. Here we're taking the 3x, just the first term, and the first term, 3x divided into 3x. Oh, that goes 1 time. Goes exactly 1 time. Then we multiply back. 7 times 4 is 28. 1 times 3x minus 1. Oops, messed that up. Why is the 3x positive? Let me highlight that. We subtracted a negative 3x. So this is 0 minus negative 3. Remember, when we subtract a negative, that means it's 0 plus 3. So that would be 3. Same thing here. 0 minus a negative 3x. So that's why when they did it in the video, what they did is they distributed this negative 1 and then they added. So they said, if I have 9x squared plus 0x, and if that makes more sense to you, when they had this underneath here, 9x squared minus 3x, when they were subtracting, they said, if you want to, think of this as a negative 1 and distribute it. So instead of negative 1, you got negative 9x squared, and negative 1 times negative 3x is positive 3x. Then you can do away with this and just add these. 9x plus negative 9x is 0. 0 plus 3 is 3x. So you can distribute the negative 1 to both of them and add them. Or if you remember, we subtract 9x squared minus 9x squared is 0. 0 minus negative 3 is a positive. Whichever way makes the most sense to you. If you want to distribute it, or if you can remember you're subtracting. And you're subtracting everything in the parentheses. So let's subtract this and subtract that. So when we multiply the 1 times 3x minus 1, we get 3x minus 1. And when we subtract, again, I'm subtracting everything. So if you want to, you can make that negative 3x plus 1. If you distribute that negative 1, negative 3x plus 1. 3x minus 3x is 0. 6 minus negative 1 is 7. Because again, I subtracted a negative. There's nothing else to bring down, so this is the remainder. So the answer, when you divide 3x minus 1 into 9x squared plus 0x plus 6, f of x by g of x, the answer is 3x plus 1 plus, we've got a remainder of 7 3x minus 1s. Just like over here, 7 times 4 is 28. When we subtract, we have a remainder of 3. So the answer is 47 and 3/4. 3/4. Because we had a remainder of 3. Here we had a remainder of 7. So it's 7 3x minus 1s. Because that's what we were dividing by. Then I'll leave that there for a minute to kind of chew on that. So we took 9x squared plus 6. We divided it by 3x minus 1. And what we ended up was 3x plus 1 plus 7 over 3x minus 1. Which means these are not factors. These are not the factors of this because there's a remainder. If these were the factors, remainder would have been 0 because they would have fit perfectly dividing that into that. All right, so over here was just an example of how it works with grade school math compared to polynomials. Same process, grade school math, polynomials. It's just we got a lot more to keep track of with negatives and x squared and x, everything in the right column. Gets a little tricky if we're not careful. So let's see. They're going through the same problem right here that we just did on paper. They set up the problem. They included the 0x, which is very important. They divided the 3x into the 9x squared and said, oh, 3x is our first term. So it goes right above the 0x. They multiplied that times the 3x minus 1. So that's 9x squared minus 3x. Now they have to subtract that. So they distributed. So when you subtract the 9x squared, the 9x squared, it's a 0. 0 minus a negative becomes a plus. You got positive 3x. Bring down the next term, the plus 6, and repeat. Divide 3x into 3x. It's 1. You multiply, and you end up with a remainder of 7. So 3x plus 1 plus 7, 3x minus 1s. Says, what would have happened if the 0x had not been included? See, then you got that 6 minus 3x thing that doesn't work. We can't combine those. Take a look at the quotients. The division resulted in a remainder. This indicates the divisor is not a factor of the dividend polynomial. If it was a factor, the remainder would be 0. 0. Let's look at page 3. All right, here's an application of long division. Like, okay, when can we do something with this to make it make a little sense? So if we said the volume of this box is represented by this function, I'm going to write this down. Okay, so we've got this box, right? We got this long box. And we know the volume is represented by this. X to the third plus 4x squared minus 31x minus 70 is the volume. And we know volume is length times width times height, right? And we know the length is x plus 7. And we know the width front to back is x minus 5. So what we don't know is what is the height. So if we know length times width times height, we just got to, so if we want to know what the height is, divide length times width on both sides. So height is the volume divided by the length times the width. So we want to find the height of this. There is more than one way to do this. We could multiply the length times the width. X plus 7 times x minus 5, and we get some kind of x squared equation. And then we could divide that x squared equation in here. But that might be even more trickier. So let's do this one at a time. So this is the same thing. Height is the same thing as dividing the volume by the length, and then dividing that by the width. I'm gonna put a capital L just to make that little. So let's take this first and divide it by the length. X plus 7 is going to be over here. X to the third plus 4x squared minus 31x minus 70. We've got an x to the third, an x squared, an x, and a 70. We don't have any missing terms that we have to account for because it has all of the terms. So we want to divide the x into the x to the third. So that goes in there x squared, right? If we have x times x times x divided by x, these cancel each other out, and we've just got x squared left. So two terms, we need to put the answer into the second one, x squared. X squared times x plus 7. X to the third plus 7x squared. Multiplying this by this, right? Now we have to subtract that. We're subtracting x to the third plus 7x squared from this. So x third minus x third, that's just 0. 4x squared minus 7x squared. So that's minus 3x squared. Let's bring down the next term, minus 31x. All right, all we have to look at is the first term, negative 3x squared, and we divide it by x. X divided into negative 3x squared is negative 3x. So when we multiply now, negative 3x times x plus 7, negative 3x times x is negative 3x squared, which it should be because we divided x out of it. So when we multiply it back, it should end up the same thing. Negative 3x times 7 is negative 21x. And again, now we're going to subtract. So if we're subtracting and they're both negatives, that means we can make them positive. Subtracting a negative. So this is 0. Negative 31x plus 21x is negative 10x minus 70 when we bring that next term down. Negative 10x minus 70. So negative 10x divided by x. Again, just the first term. Just the first term. Remember, we look at the first term when we divide that. X goes into negative 10x, negative 10 times. Negative 10 times this is negative 10x. Negative 10 times 7 is negative 70. Oh, look at there. If we subtract this, remainder of 0. Negative 10x minus 70 minus negative 10x minus 70. So what we found out is when we divide this by x plus 7, we get this. So that means these are, if we multiply these together, x squared minus 3x minus 10, multiply those back together, that would get you back to this original polynomial, this one right here. All right, let's continue this on another sheet of paper. So now we have divided the volume by the length, and we ended up with this. So now we can take this x squared minus 3x minus 10. That's what the volume is after you divide the length out of it. So now let's divide the width. The width is x minus 5. Let's divide this. X divided into x squared. So x squared divided by x is x, and it goes over the second term because there's two terms here. X times x is x squared. X times negative 5 is negative 5x. Subtract this, 0. Negative 3x minus negative 5x. Minus a negative, minus a negative. That means we add. So this is 2x. We bring down the next term. X divided into 2x. Well, it goes in there 2 times. 2 times x is 2x. 2 times negative 5 is negative 10. 2x minus 10, subtracting 2x minus 10, also has a remainder 0. So that means our length is x plus 7 because they gave us that. Our width is x minus 5. And our height is x plus 2. Now we know the length, width, and height because we divided the length out. And since it had a remainder of 0, that means we can start with this. This is what's left. When you take out the length, this is what's left. So we took what's left and divided the width out, and this is what was left, which had to be the height. So let's check to make sure we're right. So if we have x plus 7 times x minus 5 times x plus 2, that's the length times the width times the height. It should equal the volume, which is this right here. This is our volume. So let's multiply those together and see if that equals the volume. So since we have 3 things being multiplied together, we can multiply them in any order, right? Because if we're multiplying 2 times 3 times 4, we can multiply 2 times 3 first, or we can multiply 3 times 4 first. It doesn't matter. We're going to get the same answer. So let's just multiply the second ones together. So this will be x plus 7 times x. Remember, we're going to distribute x squared, x times 2, negative 5 times x, negative 5 times 2. Now we can combine like terms. So we got x plus 7 times x squared plus 2x minus 5x. Now let's multiply these together. X times x squared is x to the third. X times negative 3x, negative 3x squared. X times negative 10. Okay, that's the x taken times every term. Now we got to take the 7 times every term. 7x squared. 7 times negative 3, 21x. 7 times negative 10 is negative 70. Let's combine our like terms. There's only one x to the third. Nothing to combine there. We have two x squared terms. Negative 3x squared, positive 7x squared. Negative 3, positive 7. So we got 4x squared. So those have been used. That's been used. We have two x terms. We have a negative 10x and a negative 21x. They're both negative, so combining them makes a negative 31x. And then we've got negative 70. Huh. Well, look what we started with. X to the third plus 4x squared minus 31x minus 70. Yes, when we multiply these three together, they do equal our original polynomial. So that is what it is when you divide it out. It all checks out. These are absolutely the three factors of this large polynomial equation. I kind of put that out there. And it has all of that right here in the lesson. They go through the same thing. First, multiply the binomials. So they're going to multiply them together first and then divide that into the volume. That's another way to do it. So then they said, okay, what is it? And they want us to enter everything there. I'll leave that if you want to go back through that. Here's another one example. Polynomials divided by polynomials. This uses 4x squared plus 27x minus 7, divides it by x plus 7. So that'd be a good one to try on paper and then check to see if you did the same steps and came up with the same answer. Then they check it there. Check answer. Oh, example 2. Here's the second one. So there's a couple of good examples there that you can go through and try and, here's the lesson summary. Lesson summary and long division. You divide, multiply, subtract, bring down, repeat. That you knew from grade school. The same steps have not changed. We do the exact same thing. Here's where it'll mess you up. Missing terms. If you're missing something, 0x squared. Look at this one, x to the fourth minus 1. So you'd have x to the fourth plus 0x to the third plus 0x to the squared plus 0x. You got to get any missing terms you have to account for. And if the quotient has no remainder, it's a factor. Let's look at the assignment that goes with this first lesson. There are several practice problems. Let me go back and look at that real quick just to show you practice problems, because this can be real confusing. If you don't practice this, you're going to be lost.
Oh, yeah.
Divide this by 5. So they start out real simple, just dividing by one number. So that one's pretty easy, right? It'd be that one, right? Yes. The next one, divide by 7x. Gets a little trickier, but still you can do that. Be that one, right? Yep. And they show you how to do it. This one divides by 9x to the third. And then there's more practice problems here. Divide by x plus 7. And you can check your work right here. And there's 3 of them. Divide by x minus 5. Divide by 6x plus 1 into that. Another page of practice problems on page 5. All right, so if you divide 40x squared plus 8x plus 20 by 4, you should get one of these answers. So you just drop it in there. Then work this one. Should get one of these answers. So it's got all the answers for you, and it's got 3 pages of this. Three slides of that. All right, let's look at the assignment that goes with this first lesson. Divide this by 12x. Divide f of x by 8x squared. Divide this by x minus 4. Divide f of x by 2x plus 5. And here's another one of those volume. The volume is this. Here's the length. Here's the height. What's the width? So divide these two into that. You should get one of these answers. Yes, I know I haven't answered. Thank you. All right, I want to talk about some theorems of algebra. So most people, even if they're not mathematically minded, they've heard of the Pythagorean theorem. If you say the Pythagorean theorem, there's a lot of people that go, oh yeah, I remember that. Now they may not remember what it is. A squared plus b squared equals c squared, but that's one of the most common one that people will remember from their math days. But what is a theorem? A theorem is a statement, doesn't have to be mathematical, that's been proven by experimentation. A theorem has been proven. It's time to discover 3 very important theorems. So first, let's talk about the fundamental theorem of algebra. Here we go. The fundamental theorem of algebra. And I'm not gonna use their notes on this. We're gonna put our own notes for the fundamental theorem of algebra because they're going down a different path, and it's a lot simpler than what they have there. Fundamental theorem of algebra. What does the fundamental theorem of algebra say? The degree of the polynomial equals the number of solutions. Or zeros. Or x-intercepts. Well, no, let's not say x-intercepts because that's not true. Solutions or zeros are the same thing. So this is what the fundamental theorem of algebra says. The degree of the polynomial equals the number of solutions. Mr. Brock's handwriting is not that good today, guys. Let me sharpen that. Equals the number of solutions. Let's write down some examples to say, huh? Yeah. What are you saying here, Mr. Brock? Let's say x squared minus 5x plus 1. Let's say equals 0. How many solutions are there? This is a quadratic equation, right? There's an x squared. How many solutions does the quadratic equation want? If we were to graph that and see how many times does it touch the x-axis, which is the zeros of it, this one may not have any because it may have imaginary zeros. 2 solutions. X plus 7. 1 solution. Let's see if you can catch on to the pattern here. X to the 6th minus 2x to the 4th plus 3x third minus x plus 2. How many solutions does this have? 6 solutions. How do you know it, Mr. Brock? You just made that up. Well, if we did the math, we'd find 6 solutions. How about 3x to the 17th minus 7x to the 14th plus 3x to the 10th minus 2x to the 3rd plus 1. Mr. Brock, don't make us solve that. No, we don't want to solve that. Because if it did, it would have 17 solutions. Now, it could be that some of these solutions duplicate, like maybe -1, -1, -1. Maybe that's 3 of the solutions. But what I want you to see is the fundamental theorem of algebra says the degree of the polynomial equals the number of solutions. Now you see what I'm talking about when I talk about the degree of the polynomial? What's the largest exponent? That's how we identify polynomials, by their degree. Their degree is equal to the largest exponent. And that is the number of solutions they have. Now, some of those may be imaginary solutions. They may not be all real solutions. They may be irrational solutions. They may not be integers, but there are that many solutions. The degree of the polynomial equals the number of solutions. And some great examples to write down is something like I did. You can make up your own if you want to, but just make sure that the number of solutions equals the largest exponent in whatever polynomial that you're putting in your notes. X squared minus 5x plus 1 equals 0. X plus 7 equals 0. So notice with x plus 7, this is one of those things that we don't write again, but that's really x to the first power. We don't ever write to the first power because everything's, 7 is to the first power. 2 is to the first power. It's x is to the first power. We don't write that because it's unneeded. It's not necessary. But there you go. So you should have that in your notes on the fundamental theorem of algebra. Which are like, why did I not learn the fundamental theorem of algebra first? Should be the first thing. Fundamentally, this is what algebra is. Well, you kind of did. They probably just didn't formally tell you that is the fundamental theorem of algebra. So they start out with this quadratic equation, x squared plus 11x plus 18 equals 0. They check the discriminant, which we have looked at, b squared minus 4ac. We looked at that in the quadratics unit a lot. And they said, oh, x squared minus 4ac equals 49. That's a perfect square. So this will have two solutions. And when they factor it or graph it, they find the solutions are at -9 and -2. And those are the solutions. Those are the zeros. And since it's an x squared, we expect it to have two solutions. And it did, -9, -2. Pay attention to where this function crosses the x-axis. The x-axis represents the real number solutions. Right? That's why they're called the zeros of the function. The zeros, because that's where y equals 0, where the function equals 0. So there are two zeros to this function, and the degree of the function is 2. Right? So then they take another example. Let's factor this cubic equation, x to the third minus 12x squared plus 35x. And they graph it, and they find out there's 3 solutions, 0, 5, and 7. 3 solutions. And it's a third degree polynomial, x to the third, and it has 3 solutions. That's all because of the fundamental theorem of algebra. All right, let's go ahead and take a moment just to check out this first video.
The degree of the polynomial function is 2, so the fundamental theorem of algebra indicates that the function has 2 zeros. The zeros of the function are the values of x, which make the function equal to 0. So, replace the function notation f of x with 0 to begin solving for x. To find the zeros of this function, first verify that x squared minus 3x minus 28 can be factored, using the discriminant b squared minus 4ac. The discriminant is 121, which is a perfect square. So, x squared minus 3x minus 28 can be factored. The 3 terms have no common factor, so factor into 2 binomials. Now, find the factors of the last term, -28, that sum to the middle coefficient of -3.
Fortunately, we just learned how to do this last unit with all the quadratics.
The factors of 4 and -7 satisfy both conditions. So, those are the numbers that fit into the second position of each binomial factor. The zero product property states that for these factors to result in a product of 0, one or both of them must equal 0. Therefore, the zeros of f of x equals x squared minus 3x minus 28 are x equals -4 and x equals 7. The x-intercepts of the graph of the function confirm these zeros.
There you go. So they checked it by graphing it right there. -4 and 7 are the two solutions. And since it's x squared, we would expect it to have two solutions, according to the fundamental theorem of algebra. You have a second example here. This one, oh, I love that. Find the zeros. I'm going to write this in our notes because sometimes students see something like this and they make it oh so hard. They gave us the function in factored form. See, this is the four factors. If we multiply those together, we'll have an x to the fourth equation because we had x times x times x times x. So we know there are four solutions. Because of the fundamental theorem of algebra, we're looking for four solutions. When they give you a function that's in factored form and says find the solutions, do not make this hard. This will be the easiest way you'll ever find the solutions, is for them to give it to you already in factored form. Because you just have to set it equal to 0. Rewriting the whole thing. So if this equals 0, when you multiply these together, at least one of these has to be a 0. So you get the four solutions this way. X plus 2 equals 0, or x plus 2 equals 0, or x minus 1 equals 0, or x minus 3 equals 0. Subtract 2 from both sides. Subtract 2 from both sides. Add 1. Add 3. X equals -2. X equals -2. X equals 1. X equals 3. That's the four solutions. What makes that 0? If x is -2, -2 plus 2 is 0. What about this one? If x is -2, -2 plus 2 is 0. X minus 1. If x is 1, 1 minus 1 equals 0. If x is 3, 3 minus 3 equals 0. There's the four solutions. Now, two of these repeat. So the solutions are 1, I'll put them in order. The solutions are -2, -2, 1, and 3. Or you might see it written as 4, 3, 1, -2 with a multiplicity of 2. Multiplicity, that's a word they like to throw in there from time to time. That means there's multiple number 2s, -2s. -2 with a multiplicity of 2. Right. So there's four solutions there: 3, 1, -2, and -2. But yes, if they give it to you in factored form, you've almost got the answer already. Just set those four factors equal to 0 and solve. X plus 2 equals 0. So x is -2. X minus 1 is 0. So x is 1. They make that almost, they've almost given you the answer. So there's a video of that. And more in the fundamental theorem of algebra. Let's look at the other two theorems. Let's look at the factor theorem. All right, the factor theorem. Let me write this down. Factor theorem. Okay. So in order to understand the factor theorem, first you got to understand what a factor is, right? A factor is a number, a variable, or a polynomial that divides into another number, factor, or polynomial without a remainder, right? Let's talk about that real quick. What is a factor? Factors. What is a factor of 24? Factors of 24. Let's see. Well, technically 1 and 24 are, but we don't really usually count those as factors. 2 is a factor of 24 because it'll divide into it evenly without any remainders. 3 will divide without any remainders. 4 divides. 5 is not a factor because if we divide 5 into 24, we get a remainder of 4. But 6 will divide in, 8 will divide in, and 12 will divide in. Those are all factors of 24 because 2 divided in 24 equals 12, 3 divided in 24 equals 8, 4 divided in 24 equals 6, and vice versa. And then, 1 and 24 are kind of factors, but that just itself isn't 1. So we really mean this when we ask what the factors are. So understanding what a factor is, it means that when you divide, you have a remainder of 0. So it was discovered through factoring that the binomials x plus 2 and x plus 9 were factors of x squared plus 11x plus 18 because there is no remainder. So let's write down some words for the factor theorem. If you divide a polynomial, don't think faster than you're right, Mr. Brock, by another polynomial, and the remainder is 0, then the divisor of the divisor polynomial is a factor of the original polynomial. Okay, that's going to be our factor theorem right there. You can write that however it makes sense in your notes. But if you divide a polynomial by another polynomial and the remainder is 0, that's the important part of that. If that's true, then the divisor polynomial is a factor of the original polynomial. So like when we went in here and we took x to the third plus 4 squared minus 30x, 31x minus 70, and we divided x plus 7 into that, we got a remainder of 0. That means this is a factor of this original one. That's the one. That's the divisor. That's why I divided into there. This is the quotient up here. This is the dividend, divisor, dividend, quotient. The divisor polynomial is a factor of the original polynomial. Write that down however that makes sense to you. But that's what the factor theorem tells us. The factor says, yes, that would be a factor if the remainder is 0 when you divide. So they have showing that x plus 2 is a factor of this polynomial, has a remainder of 0. Then they divide the other one. If they would divide x plus 9 in, it's also a factor. See, because that's what you're left with the quotient. Those two are the factors of the original. Okay, so this asks, is x plus 12 a factor of x squared plus 6x minus 72? Is that a factor? So here's the first step. Set up a division problem. Divide it. So x plus 12 would be divided into x squared plus 6x minus 72. When you do the math, you get x minus 6 as the quotient with a remainder of 0. So the answer is yes, x plus 12 is a factor of x squared plus 6x minus 72. And here's more on the factor theorem, which means it's basically another example of that. Is x minus 2 a factor of this function? They did the division, and they have a remainder of 12. So it's not 0, it's 12, so it's not a factor because the example is not 0 in the remainder. It's got a remainder of 12. Here's one. Is this one a factor of that? Well, the remainder was 6. So x minus 7 is not a factor because you're getting remainders that are not 0. All right, what's our last theorem? The remainder theorem. The remainder theorem. This is kind of cool. Okay, let me see. All right, we're going to do this like this. We're going to illustrate the remainder theorem by first doing some division. All right, so we have this problem right here. X plus 1 divided into x squared plus 11x plus 16. So we're going to find out if this is a factor using the factor theorem. And then we're going to talk about the remainder theorem. X plus 1 divided into x squared plus 11x plus 16. So we look at the first terms. X squared divided by x is x. We multiply this down, x times x plus 1. X times x plus 1 is x squared plus x, right? 1x. We have to subtract that. X squared minus x squared is just 0. 11x minus x. So we have 10x plus 16. How many times does x go into 10x? 10 times. So we divide 10x by x, we get 10. So 10 times x plus 1 is 10x plus 10. Right? Because 10 times x is 10x and 10 times 1 is 10. Subtract this. 10x minus 10x is 0. 16 minus 10. Okay, this is the remainder. This is not a factor of this. But let me show you something. If I write this in function form, function notation, okay, and if let's see, how do they do that? How do they show that? Yes, if I took this x plus 1 and set it equal to 0, x plus 1 equals 0. This is what my divisor was, right? Subtract 1, solve for x. X equals negative 1. So if I take that, and I take this negative 1, I said, what is f of negative 1? I'm just going to substitute that negative 1 into my function. So that means this is negative 1 squared plus 11 times negative 1 plus 16. So still finding what f of negative 1 is. Negative 1 squared. That's negative 1 times negative 1. That's a positive 1. Plus 11 times negative 1. 11 times a negative 1. So that would be minus 11 plus 16. 1 minus 11 is negative 10, right? 1 minus 11 is negative 10. Negative 10 plus 16 is 6. What do you notice there? Wait a minute. When I substitute the x value for what makes this 0, x plus 1 equals 0, so if x is negative 1, I got the same number of what the remainder is. Oh, you tell me this gave me the remainder without doing all of this long division? Yes. You want to test that to see if that works? Let's see. Here's one. Well, we'd have to deal with a fraction on that one. I don't know if we want to do that. Do I have another one? Good. Oh, yeah, here's one. Let's try this one. So we don't have to use a fraction. We can use a fraction, but all right. So here I'm taking f of x. I'll write this down and I'll move it up on the page. X squared minus 3x minus 10. And I originally divided it by x minus 5. Okay, so I divided x minus 5 into this on this other page up here. So if x minus 5, that means x equals 5. Because if I set that equal to 0, I would add 5 to both sides. So if I take f of 5, it would mean this would be 5 squared minus 3 times 5 minus 10. 5 squared is 25. Minus 3 times 5, minus 15, minus 10. 25 minus 15 minus 10. Is that what the remainder was? It was. When I divided x minus 5 into that, I got a remainder of 0. So if I substitute 5 into that, because x minus 5 equals 0, I also got 0. This is giving me the remainder when I substitute that in. Well, that is just pretty darn cool. Let me go back and see what this says about that. When the opposite of the constant term of the binomial is substituted for x in the function, the result is equal to the remainder when the function is divided by the binomial. This is the remainder theorem. So let's see, how can we write that in a way that makes sense? When the opposite of a constant, and we're going to do, for example, negative 3 from a binomial, and the binomial would be x plus 3. So since this is plus 3, we would substitute negative 3. When the opposite of a constant, wow, Mr. Brock, come on. When the opposite of a constant, like negative 3, from a binomial is substituted for x in a polynomial, the result equals the remainder found from dividing the binomial into the polynomial. If that doesn't make sense to you, write it in a way that does make sense. Knowing that what we're talking about, we're saying the remainder theorem says when the opposite of a constant, and I put an example like negative 3 from the binomial x plus 3, like if we were dividing x plus 3 into a polynomial, we would use negative 3. And when we substitute that negative 3 in for x in some polynomial, whatever that polynomial is, the result equals the remainder found from dividing the binomial into the polynomial. So if we had some polynomial, 3x to the fourth minus 2x squared minus 1, if we substitute -3 into that, whatever number that gives us would equal the remainder if we divided x plus 3 into that. It would be the exact same thing. Substituting -3 would give us the same answer as dividing by x plus 3 for what the remainder is. It's just a shortcut to find the remainder, to know is it a factor or not. Because I don't want to divide this x plus 3 into this, because this is the fourth degree, this is the second degree, which means I got to add a 0x to the third, and I got to add a 0x. So I've got 5 terms here, and I'm dividing x plus 3 in there, and that's going to take a while. But if I just want to substitute -3 in, I can find out real quick whether or not the remainder is 0 or not. That's going to save me a lot of time. Is that 0? I say write that in whatever way it makes sense, but it kind of helps to have examples written down anytime we write down something like this. An example, like this is a great example, showing the remainder was 6 when we did the division, and it equals 6 when we did substitution. So I love having examples written with this kind of stuff where it gets a little wordy. A little wordy. All right, the important note here. The remainder theorem delivers some important facts. Given the polynomial function f of x and some number a, if x minus a is a factor, then a is a 0. You can prove it's a factor by using long division or using factoring methods. So if a is a 0 of the polynomial, that'll be the x-intercept. Substituting a will equal 0, and dividing a will be 0. All right, there's more examples if you want to write down more examples in your notes or want to print these off and use them as notes. This shows find the remainder. And look, this is a big old long x to the fourth, and you're doing this next way. So you can do it with division. There's the long division. Or you can just substitute it in. And either way, you find out -9 was the result. So it is not a factor, because that is the remainder and the remainder theorem there. Let's look at the lesson summary. What key features of a polynomial can be found with the fundamental theorem of algebra and the factor theorem? How's the remainder theorem allow for zeros to be identified? So it tells you what a theorem is, talks about the fundamental theorem of algebra. The factor theorem shows you when it's 0, that this is a factor of the divisor, the dividend. And then the remainder theorem, how it will tell you the exact same thing as far as the remainder. And there's that little summary at the end. Let's see what kind of practice problems they have for you here. Find the zeros. So find the zeros of all 3 of those, and then drag this to which one of these equations has a 0 of -2. I'm going to say it's that one. One of them has a 0 of -7. I'm going to say it's that one. -4, that one. 5, that one. 9. This is not as hard as it looks, because some of these are in factored form. That one. Ha ha ha. There we go. I got all 8 of them. Now you can reset and try that. Page 5. More, according to the fundamental theorem of algebra. Oh, this is the easiest question you'll have, and I think I have one of these on the final as well. According to the fundamental theorem of algebra, how many zeros does this function have? 0, 2, 5, or 7? This is the easiest question we'll give you in all of Algebra 2. All you have to know is the fundamental theorem of algebra says the degree of the equation equals the number of zeros or solutions. This is a 5th degree equation. That's the largest exponent, which means it has 5 solutions. All you got to do is figure out which number is bigger. Is 5 bigger than 4? What are the zeros? Just set that equal to 0 and solve for x. You'll have two answers because it's x squared, so you'll have two answers. All right, let's go look at the assignment for this because we're about out of time. According to the fundamental theorem of algebra, how many zeros does this equation have? Which of the following is a zero? And this is in factored form. Thank you. I already know the 3 zeros just by looking at the factors. If x minus 8, is x minus 8 a factor of this function? Okay. Let's figure that out and then figure out the right description. Okay, find the remainder of this when it's divided by x minus 5. So you have two ways to do that. Either the factor theorem or the remainder theorem. And find the remainder when this is divided by x minus 3. 3 theorems today. In Algebra 3, we learned 5 theorems. So we got it easy here in Algebra 2. If you're in Algebra 3 next year, we'll learn 5 theorems. Fun stuff. I love these theorems, actually. This is good stuff. When we get into the fundamental theorem of algebra, when we get into all of these remainder theorems, factor theorems, that's when you get into the good stuff, the college level stuff where they're really digging into the meat of how math works and all that good stuff. So, all right. You have these 2 assignments. Next week, you'll have a video to watch, assignments, and then finals are after that. And they'll be at noon on Wednesday the 17th. We'll meet here and take the final together as a class on the Google Meet. You'll have an hour and 50 minutes, but you can leave when you're done. So, all right, guys, I'll be here Wednesday and Friday if you need help with anything. Otherwise, have a great week. We'll catch you next time.